Okay, cool. Good morning. How was that party last night? Oh yeah, one of those. Yeah, a little too late. Yeah, my voice was just from the singing, right? Just from the singing, nothing else. Voice was feeling a little rough this morning. Listen, it's the last Cisco U session on the last day, so thank you for coming. Wasn't sure what the turnout would be like. I'm Canadian, so I felt like I should start by apologizing for something. Sorry about the smoke. It's not funny, but anyway, so sorry about that. Listen, whose first Cisco U session? Maybe. And keep your hand up if you've been to 2 of our sessions, 3, 4, 5, 6. Very good. Well, again, thanks for coming out. Really appreciate it. Worked hard putting this together for you. Hopefully you got good nuggets of knowledge in these little 30-minute sessions. Programmability with John, Hank, some automation, some routing. Obviously talking a lot about learning and certifications. I want to talk a little bit about this morning. So some SD-WAN. Who's got SD-WAN already at work? And who's afraid of SD-WAN? No, I'm just, okay, all right. It's not going to be a deep dive, right? I called it a mini boot camp or just, yeah, a mini boot camp. We're just going to talk about what it is, what it looks like, different flavors of it, terminology, why the heck would you be interested in this? What is the business proposal? And I want to wrap up, obviously, and look at some of the learning content that we've developed and we've built so that if you're interested to know more, you want to take a class. We've got a 2-day course. We've got a 3-day course. These are like ILT, but they're also available on our e-learning platform on Cisco U. We've got the 5-day, which maps to the EN SD-WAN exam. So we've got lots of learning content, and we can have a little look at that. So very simple agenda, a bit of learning and then a bit of fun. So I don't know if you have been following me on Twitter. I've been talking a lot about maple syrup candy that I've brought. So I have a kilo of that I'm going to hand out today just to kind of keep you kind of going. I'm sure you've had a few mimosas, maybe a few too many. No, anyways. So we'll talk about SD-WAN, and then I've got also a copy of my Cisco Press book that I'll hand out towards the end. So again, just a thank you for coming out and sitting down with me. So the first thing I want to mention, I don't know if you saw this through the keynote. If you've looked at any of the press releases, there's some new naming conventions that are coming. Some products are changing names, and this word is starting to appear more and more now. So it used to be just Cisco SD-WAN. Now there's a lot of a rebrand happening here, so it's going to be called Cisco Catalyst SD-WAN. I've brought in some of the new names, and I'll show you where they apply and what that looks like. So maybe you'll be familiar with some of the old names, but I wanted to at least show you what the new names for the products are as well. So before we look at SD-WAN, let's just have a chat first about some of the issues that you're facing in maybe your traditional network deployments. And this is just a list I came up with. I'm sure if I asked you to like raise your hand and tell me what your issues are, it would even go beyond that. So today, what kind of issues are we seeing with our traditional network deployments from 10, 15, 20 years ago, whatever the case may be, across the top, but we can kind of go a little bit deeper in here. I mean, our networks are complex. They're getting more complex. We've got all kinds of solutions deployed on-prem, in the cloud, in our DC, in our remote locations, in our branch offices. People are connecting from home, obviously, through the pandemic. A lot of hybrid work, remote work. So it's complex to operate. It's complex to troubleshoot, to even manage to a certain extent. It's costing a lot of money here. And I'm not talking about the cost of the solution itself, but I'm also talking about the cost of bringing up new MPLS links. They take a while to bring up. They're expensive. And so there's that to keep in mind as well. These kind of go hand in hand, right? We're doing a lot more in the cloud. And so I don't get a good sense of my apps that are maybe running in the cloud, my Office 365, my Dropbox, my SAP, whatever the case may be. And again, I don't have a good sense of who's using those apps. What are they doing with them? Who's controlling that access? And speaking of access control, how am I securing this network? Is everything at the data center? Again, I've got a diagram coming up, and I'm sure it's gonna resonate with a lot of you, where most of our security stack historically would have been at our data center, at our headquarters, everything kind of going through there before heading off somewhere. So can we change that paradigm a little bit and improve it? And not just improve it for you guys that are actually managing the network, but improve it for your customers, your staff who are actually using these apps that are in the cloud or at the data center. And don't we want a lot more of this and less of that, right? So we want those faster links. We want to be able to access that cloud quickly, efficiently. I'm being told I should use the internet instead of MPLS, but if I use the internet, that's not too safe. Not much of an SLA there either. How can I improve on that as well? So just some of the things that came to mind to me anyways when I was thinking of those traditional network challenges. Obviously, I don't want this, right? I want my staff to be efficient, quickly get the data they need off the cloud on-prem, respond to those customers quickly, and get the job done. So I'm not trying to say that SD-WAN is like some sort of panacea. It's going to fix everything. It's not what I'm saying. But maybe we can improve a few things that you're struggling with right now. So as I said, this is maybe what it looked like up until pretty recently. And maybe your network actually still looks a little bit like this. So we've got a bunch of branch offices connecting back to our headquarters, and they're maybe using just those traditional MPLS links because they're solid. I know how they work. They're predictable. It's all good. They're safe. I've got a lot of people that are working from home. They're connecting back through some sort of a VPN connection. And most of my workloads, most of my servers, my apps, my security stack is all in here. And so you'll hear this word a lot when we talk about SD-WAN, hairpinning your traffic. I don't want to have to do this all the time to get into here. Same thing here. I'd like to be more efficient for my internet access. Yes, I still need to get to the data center, fair enough, but I'd like to maybe improve that situation a little bit. And so we need to maybe move to another kind of topology, another kind of paradigm in the way that we deploy our networks. So again, I still have the same folks at my branch offices, and I've got people working from home, working on the road. I need them to be able to quickly get to all the stuff that you see at the top. There's a lot of stuff at the top there. I've got my apps, right? So I've got my SaaS applications. I've got my workloads that are running in AWS, Microsoft Azure, GCP. I've got perhaps even, obviously, just internet access. And maybe I even have a private cloud data center that's running my Oracle and some private databases on premises as well. So I'd like to move to this, right? Accessing that from anywhere, anytime, obviously securely as well. So this is what we're trying to achieve here. So is this making sense so far? I've been just trying to set the scene, right? We're just moving towards a suggestion at this point. Maybe we can do it differently and better. So when I'm talking about SD-WAN, these are the four things that come to mind for me immediately. I'd like to be able to deploy this anywhere. So it doesn't matter if it's at a branch location, co-location even. I'd like to be able to leverage that as a service as well. I'd like to be able to leverage my cloud as a location as well, and obviously people working from home. So I want to be able to do this anywhere. And I'd like to use any transport if possible. Maybe not as my primary, but I'd like some backup options, right? So of course, I've got my MPLS, my internet connections, but maybe some satellite or 5G for that branch location in northern Canada somewhere, right? So I'd like to maybe try to get a combination of transports, some that might be expensive, some that are less expensive, some that have SLA, some that have a poor SLA, but still, I'd like to have those options for backup transports. And I'd like to be able to deliver across this SD-WAN solution all the services I need. Doesn't matter if it's a security service. Doesn't matter if we're talking about optimizing for the cloud. Doesn't matter if we're talking about analytics, right? I want to see what's going on in that data. Why is the data taking longer through this link than it does through this one? What do I need to do to improve that situation? I'd like some voice support as well, obviously, through that, right? I don't want that to be an afterthought. I'm already using my voice traffic across my WAN. I need to be able to support that as well. And maybe I've got SD access running in my campus. I want to be able to integrate that, have these two things talking to each other, so it's supported as well. So the last one at the top, how am I going to actually deploy this? Well, you've got fundamentally two options. You could do a full on-premises and do everything yourself, your controllers, do it all yourself, or you could get it done in the cloud, right? With Cisco, we'll spin up your controllers for you, we'll help you get that fabric up and running, and then you go and deploy your WAN edge devices at your branch, your data center, and build your fabric that way. So that's another way of doing it as well. So Again, a lot of keywords up there that I'm sure you've heard all week. I want to be able to automate some of this stuff. If you were here for John's session, he'd say, I want to AI that. Like, I want to use Chat GPT to push a policy to my WAN edge devices. And I'd be like, John, dude, I'm with you. So I want to be able to do that as well, right? So these are some of the different keywords for me anyways that come to mind when I'm thinking of SD-WAN and what it's bringing to the table. I'm going to go through these quickly. They're just, again, some like top of mind. What are the features of SD-WAN, right? Someone comes up to me and said, what's SD-WAN all about? So this is what I would come up with right away. First of all, I want to be able to deploy either physical devices or virtual devices. I'm talking about like the branch devices, for example, or in the data center. It doesn't matter if they're virtual or physical. We need those to be secure. I'd like to have some sort of a redundant management process. So how do I manage this? And am I managing it on-prem or is it in the cloud? And how will I be able to access it as well if one of them goes down? This is probably the key thing that I love about SD-WAN the most. I can take a router, I can send it to a branch location, tell someone there, you know when the internet guy shows up and the link is provisioned, can you just plug this device in for me? And from that, I'll get an IP address, I'll be able to resolve a DNS name, I'll be able to contact a zero-touch provisioning service and join your fabric within moments and not have to fly out to Northern Canada. It's smoky, you don't want to go there right now, and deploy that router, right? And this is probably the key thing, right? Don't forget, we're talking about SD-WAN, so just those first two letters, SD. Same thing for SD access. What that's all about is three things. We're going to take a device and we're going to blow it open. We're going to pull the management plane out of it. We're going to pull the control plane out of it and the data plane. So we're going to have three views of it. And actually, we're going to go to 4 in SD-WAN because we're going to have an orchestration plane. But I'll get to that in just a second. So I want to be able to centralize management. If I got 1,000 routers, I don't want to have to log into each one to push a config. Again, my buddy John would say, Patrick, we would just Chat GPT that. I don't want to have to manage them individually. I want a single pane of glass to be able to manage those devices. Control plane, each router making its own decisions. That's so easy to mix up and make a mistake and screw up a config. I'd like to centralize the control plane so that I can make a decision on the control plane centrally and know that that gets pushed to all of my data plane devices. And then obviously I've got my data plane devices that are actually forwarding the traffic, building those IPsec tunnels, making sure that traffic gets to where it needs to go. This is great as well. How do you want your topology to work? Well, I'll tell you a secret. If you spin up SD-WAN and you just stand back and wait a few minutes, it's going to build full mesh for free. It's going to try to anyways, right? You get full mesh. Well, maybe you don't want full mesh. Maybe you want hub and spoke. Maybe you want a partial mesh over here and hub and spoke over here. You can click, click, build a couple of policies, and you're done. I mentioned this one already, so I won't repeat it. We do want to be able to use any transport. Now, you're going to say, how about VPNs or VRFs? Am I still isolating traffic? Well, yeah, of course. At a branch location, you've got guest access, you've got your staff, you've got your point of sales devices. They're all in their own VPNs. I would call it a VPN in SD-WAN. You would say it's a VRF. Same thing. VPN, VRF, it's the same thing in this case. So my WAN edge device, my device at that branch would have multiple VPNs. I'm going to send that traffic through that IPsec tunnel to another location. It's going to get tagged based on that VPN, and it's going to stay isolated in that VPN, right? So it's securing it and isolating it like that. I mentioned this one already. I know it's a funny looking diagram, or icon. We're going to see that one quite a bit. It's the vManage. It's our management plane. That's the little icon for that. And this is where I'm going to do all my work from there. And in case you saw SD-WAN a couple of years ago or last year, you should go have a look at it today, right? The GUI experience has changed radically from early SD-WAN, like 20.1, 2, 3 versions of code, to now 20.6, 7, 8, 9, 10, 11, and 12 that's coming out. So the GUI is so much better, easier to work with, easier to understand, way more intuitive as well. This is quite interesting. I'll have another slide on that as well in a few minutes. Basically, what we're talking about here is I've got different tunnels. Which tunnel is the best one for this traffic? So I want some analytics. I want some stats there to be able to determine my voice traffic should take this one based on an SLA. And if it doesn't match that, or if it's out of the SLA, then okay, it can fail over on this particular link. So we'll look at that, application-aware routing. Obviously, I need security. So earlier I was saying we're going to have a centralized control plane, and you must have been wondering, well, hang on a second. If I'm taking the routing intelligence out of my router, and I'm pushing policies to them to tell them what to do, I better secure that. Does that make sense? So we'll do that with DTLS. And then again, earlier I said, okay, I've got a branch location, I've got another branch location, we're gonna build an IPsec tunnel. Okay, so we're using IPsec at the data plane across those branch locations to secure the data traffic. So we've got security going up from those devices up to the control plane, management plane, and also across the bottom between those WAN edge devices. I mean, I'm repeating myself, I'm sorry, but it's key things here, right? So I wanna be able to support any kind of cloud stuff that I'm doing, my SaaS applications, my workloads in the cloud, Amazon, GCP, Azure. I want to be able to support all that. And then finally, I need my security. And this is what's really interesting with SD-WAN. I've got a couple of slides at the end. Hopefully we've got time. I tend to be a bit chatty, I'm sorry. I've got some slides on on-prem security. So what are the options for on-prem security? But also, how about if that WAN edge router at that branch location in Northern Canada can't really support URL filtering and DNS and AMP and, I mean, you name it, all of these things, the firewalling. What if it can't support that? It doesn't have the performance to do that. Maybe I can then instead leverage the cloud to offer me that security that I need. So I've got a couple of slides. If we've got time, we'll have a look at that. Everyone still with me? Okay, thanks. So this little diagram, I'm going to use it for the next 4 slides. It's just a visual on how we're breaking it all apart. I already said a few minutes ago, we're kind of blowing the device up and separating the stuff. So that's what it looks like. So across the top, we've got 2 things. We focus mostly on the management plane, but it also includes what we call the orchestration plane. So there's a couple of devices I'm going to focus on in there in just a second. So these are the old names. So I'm going to focus on the vBond in a sec and the vManage. Then we're going to work our way down to the control plane. That's where all that routing intelligence happens. That's like the brain of the operations. I'm going to call that a vSmart. Again, that's the old name. New name's coming. And then across the bottom is where all my traffic is getting actually forwarded, right? So my branches are connected there, my data center. All my locations are here, right? So that's where the actual forwarding is happening. And these funny little lines behind them are supposed to represent the IPsec tunnels that are being built between them, all right? So here we go. We're going to quickly look at all 4 of these things. So the vBond, new name, the validator. Felt like I'm in a Terminator movie or something, I don't know. Okay, what's the vBond do? Really easily. The vBond is the gatekeeper. Remember earlier I was talking about that zero-touch provisioning? I just want to plug in a router, kind of stand back, go get a coffee, come back, and it's joined my fabric. How does that happen? Well, once it connects to the internet, that device is going to reach out to our ZTP service. And the ZTP service is going to say, okay, this serial number, that belongs to, I need someone's name. This belongs to Tony's fabric. All right, Tony's fabric has this IP address for vManage and this IP address for vSmart. It's going to give that information to the WAN edge device, and then the WAN edge device is going to authenticate itself to those devices and then join the fabric. So that's the step that happens for that to occur. So that's all. It literally is the gatekeeper for the network in this case. I know this might seem really obvious, but for a lot of people, they're like, what does it actually look like? It doesn't look like anything. It's a virtual machine, right? So that's what it looks like. The control plane, here we go, new name. It used to be the vSmart. We're calling it now just the controller. Again, it's a virtual machine. And as I said, this is the brain of the operations. A lot of people think of it as a BGP route reflector. It's going to carry the routing information and then send that routing information to those WAN edge devices to tell them how to operate. And what's interesting is that you can build out policies to then say, okay, well, these devices need to know these prefixes. These ones need to know these prefixes. I'm going to filter some stuff. We're going to change the way the topology works at this point as well. I want these guys to work as a hub and spoke. This should be full mesh over here. So that's happening at the control plane. So very similar, as I said, to a route reflector. So the vManage, new name, the manager. Listen, it's just the GUI. This is where you're going to do everything. You're going to build the device configs. You're going to push your policies. You're going to do all your work from this particular device. All right? It's going to allow us to troubleshoot and monitor the network as well. And we're going to push all this using REST APIs and netconf to those devices again. And then finally, the WAN edge device. This is the device that's actually doing the data forwarding, building those IPsec tunnels. So couple of options for this. Everything else before was virtual. Now at this point, actually, there's still some virtual options, right? If I want to spin up an SD-WAN device in AWS, it's going to be a virtual router. A couple of options there. You could do a Cat 8kV, a CSR 1kV. Or if you want to go really far back, you do a traditional Viptela vEdge device, like the vEdge Cloud. But obviously, you can also buy a piece of hardware, so an actual physical router that does the SD-WAN job. A couple of things to mention about that. There's two flavors, right? The original flavor of SD-WAN when it joined the Cisco family was from an acquisition from Viptela. This was a little while ago. And so we still support and have those devices and support that operating system. But more and more, we're encouraging people to move to just an iOS XE experience, right? And so the newer devices all have iOS XE, and so it simplifies the CLI. You don't have to know a couple of different CLIs. That's just CLI, iOS. I'm familiar with iOS XE. I know how to configure this to a certain extent. So as I said, that's going to build our fabric. It's going to establish the IPsec tunnels. And the reason I mentioned this down here is because I don't want you to forget. This is all the stuff happening, let's say, across the transport. But down here, plugged up in this router, is what we call your service side, right? That's where your VPNs, where your clients, where your users, where your servers are. And maybe you've got some routing happening there. Maybe you're running, as Desiree was saying earlier, OSPF, or you're running a bit of BGP there, or RIP, or EIGRP, or whatever it is. It'll support that. And it even supports VRRP if you're not doing a routed LAN, if it's just a switch LAN, and it'll support that too. So that's all happening in the WAN edge devices. How are we doing for time? Am I okay? Cool. All right. Everyone's still here. That's great. Oh, no, someone left. That's okay. We'll just disown them later. Okay, the next few slides, I just want to have a look at a little bit of terminology, because in about 3 slides, I want to paint a picture. And before I can paint the picture, I just want you to understand what some of this terminology is. And you need to be, I'm hoping you're listening, because as I said earlier, I've got a kilo of maple syrup candy and I don't want to go home with it. See, when you leave Canada with the candy, you can't go back into the country with it. All right? So you need to make sure that I'm going to be asking you some questions. And if you get the right answer, you get a candy. Right? So, okay, so the first terminology that I want to just cover very, very quickly is OMP. It's the overlay management protocol. It is the routing protocol for this solution. This guy doesn't get a candy. It's just the routing protocol, okay? It's very similar to BGP. And I don't want you to go away saying, man, we just talked about BGP. No, it's not BGP, but it's similar in BGP in the sense that it's carrying a ton of information. It's not just carrying prefixes. It's carrying next hop information. But another thing that it does, and I find this is quite cool as well, is you can actually use it to advertise services in your fabric. I'll give you an example. Let's say you've got a couple of branch offices, and you know that when they talk to each other, you want that traffic to go through a firewall, but that firewall is in another location. You can advertise the firewall as a service in the fabric to tell branch 1, if this prefix needs to talk to that prefix at this other branch, don't just send it down that tunnel. We're going to punt it up here, inspect it, and then send it back down. That's super cool. It's going to advertise what we call TLOC routes. I know I haven't told you what this is. Bear with me. But it's very simply, it's like the next hop information. So it's going to advertise next hop. So a WAN edge router, when it boots up, it's going to want to say, hey, I've just joined the fabric. How's everyone doing? These are my IPs. This is how you can reach me, right? This is my name, and this is how you can reach me. And then the OMP routes, those are just the actual prefixes, right? So at WAN edge 1, branch 1, these are the prefixes. Branch 2, these are the prefixes. We're going to advertise that up. But again, don't forget what I mentioned earlier about the route reflector. So if I'm at branch 1 and I advertise a prefix, who am I advertising it to? I'm not advertising it to the other branches. I'm advertising it to the control plane, to vSmart, sorry, to the controller. And the controller will reflect that information to the other branches that need it. As I said, if I stand back, it's going to full mesh itself and advertise everything. But I can control that with a policy. I can say, no, these prefixes, these guys should know about it, but then these other routers shouldn't know about it. And it's secure and the whole 9 yards. So I mentioned something called a TLOC, and that's what it means. It's a transport locator. And I'll be honest with you, it sounds complicated. It's not complicated. It's basically a combination of a few things. So when a WAN edge device joins a fabric, it's going to say, hey, my name is, it's not going to say, hey, my name is Slim Shady. It's going to say, hey, my name is 10.1.1.1. And I'm connected to a couple of transports, but it's not going to call them transports. It's going to call them by a color name. So we've got a couple of different colors. They can either be a private color or a public color. So it's going to say, hey, my name is 10.1.1.1, and I'm connected to this MPLS color. and I'm connected to this internet color. So I got a private one and a public one. And I've been told that I should be using IPsec. So it advertises, those are called T-lock routes. It's going to advertise that out. Here we go. Cool, and that's why it took me hours just to get that arrow to work. So it's going to advertise that up to vSmart. Say, hey, my name is 10111. I've got these T-locks. I'm connected to these transports. This is how you can reach me. Don't forget the controller's a route reflector. Check this out. What is it going to do? Again, if you stand back, let it do its thing, it's going to send that to everybody. It's going to say, hey, we've got a new router that's just joined, 10111. You can reach it across these two transports, and it's IPsec. So you're going to need to negotiate some IPsec keys. You're going to secure that, right? So vSmart's going to help to exchange those IPsec keys. And that's when this happens. Look at this. Wait for it. That's beautiful. That took me another hour just to do that. So that's when we get the full mesh IPsec tunnels. If that's the way you want to let it do its thing. So that's what the T-locks are, that next hop information. And you can kind of see my little hint. I know it's a bit small for those of you in the back. Basically, it just says it's similar to a BGP next hop, right? So BGP is going to advertise prefixes. It's going to advertise attributes. It's going to want to advertise a next hop. That's kind of similar to what we're talking about here. Now, I just said something quite peculiar. I said, if we just leave it alone, it's going to want to build a full mesh. Now, if it's a public transport and a private transport, well, how's that going to work? Is it going to go through one, down into the other one, and then pop out the other side? Well, it depends, right? So if I've got a public transport and a private transport, and I'm lucky enough, or I've decided to implement connectivity between the two, like through my DMZ, firewall, whatever, but it works, well then, as I just finished saying, the routers are going to start talking to each other over all those transports to establish as many tunnels as possible. So on the right side of the diagram, I would get 4, right? I would get T1 to T3, so that's I used green here in this case, T1 to T3 across the top, and we have T2 to T4, that's across the bottom. But then you can see that it's also going to establish these tunnels because I've got connectivity. Now, you know where I'm going with the left side of this diagram. What happens if I don't have that connectivity? Well, don't worry about it. It's not going to do it, right? It's not going to establish those links, but it's going to want to try, and it's not smart enough to realize that actually there's no connectivity. So it's going to report back and almost call it like an error. It's going to say, hey, dude, I should be able to connect here. You've told me there's these transports. I should be able, but it's down. It doesn't realize there's actually no connectivity between the two. So you can go into vManage and tell it, actually, you know what? Stop doing that. Just establish IPsec tunnels color to color, not color to other color, basically. So that's what you're seeing across the top here. I got my T1 to T3, so that would be an IPsec tunnel. T2 to T4, another IPsec tunnel, and then it would skip these ones entirely, right? So that's how it manages that stuff. All right, cool. We get to the really neat kind of walkthrough that I've got here for you. So I'm going to paint a picture. Simple topology, 2 locations, WAN edge 1. It's got a name. Earlier I said it was a system IP. Here it is, 10.255.255.11. That's what it's called. And it's at a site. Now I need to identify that site. So a unique identifier, we're going to call it site 10. On the other side, we got 10.255.255.21, site 20. You can see we've got a couple of T-locks, right? We've got 2 transports. One's a public transport, one's a private transport. And we've got our controller at the top. So here we go. This is what happens. First thing, as I said earlier, once the devices have been allowed by the gatekeeper to join the fabric, they're not going to join the fabric right away. They have to talk to this device first, right? So we're going to bring up some DTLS tunnels to establish a secure control conversation, if you like, with those devices. And what's going to happen inside of those, that's where the OMP protocol starts running. I mentioned OMP earlier. It's the routing protocol. I need to hide that, right? I need to make that conversation secure and safe. So that's going to run inside of those tunnels. And don't forget what I mentioned. OMP is going to carry those T-lock routes. So as soon as that comes up, these devices are going to start advertising their T-locks. And hey, I'm 10.255.255.11. I'm over here, right? You can get to me through internet and through the MPLS link. Once those T-locks have been exchanged and back down again, that's how they find each other. And now we've got those IPsec tunnels that are built between them. So far, so good. What's going to happen inside that? Well, obviously, I've got user data that's going to want to, travel across that. That's fine. But I should keep an eye on those tunnels, right? I want to monitor those tunnels to make sure that they're healthy, that they're up, everything's good. So I'm going to use BFD for that. Who's heard of BFD before? Yeah, good. Bacon, fried, anyways, whatever. So we're going to use bidirectional forwarding detection to just make sure those tunnels are live, are healthy, and if they're not, quickly report the situation, tear it down, and start using maybe a different link. Now it gets interesting. Now I can go to my different locations and create those subnets. We call them a VPN. You might call them a VRF. Same thing. So I might create a VPN here. And look, I'm using the same number here. If I use the same number, guess what? They'll be able to talk to each other. And again, this could be a subnet that I'm advertising. Maybe it's directly connected. Maybe, no candy. Maybe it's directly connected. Maybe it's OSPF. Maybe it's BGP. And what's going to be interesting, folks, so hold on to your chair. We're going to redistribute. We're going to advertise. We're going to redistribute these subnets into OMP. That's how it gets brought up here, back down. And guess what I can do over here? Redistribute it back down into the routing protocol. So OMP, as I said earlier, is going to carry that reachability information. It's going to allow me to exchange those security keys that I need for IPsec. And it's going to allow me to push the different policies that I've got as well, either control plane policies or data plane policies. And again, my network has grown. I've added a new subnet, a new VPN. I've done it here as well. I'm going to exchange that information. So OMP updates are going up and down with the control plane, and we're pushing that information out. That's how it works. That's literally the fabric walkthrough that SD-WAN does. How are we doing for time? We're done? Should I continue a few more minutes? Is that okay? All right, sounds good. Yes, I am the last one. We could be here. Try the fish. No, I'm okay. Hang on a sec. When I said earlier that it would create a full mesh, how many of you freaked out? Like, what are you talking about, dude? So probably the most powerful thing in SD-WAN from a management kind of from your perspective is this. You need to build some policies. You need to make some smart decisions about how you want your routing to happen, how you're going to redistribute, whatever the case may be. You need to be able to control that. And I like this diagram, and hopefully I can make it as simple and clear as possible. Because when you start, and I'll be honest with you, when you start with SD-WAN and you start looking at policies, it can be a little bit intimidating. Okay, it can be. So I'm going to just break it down. I won't spend hours here. I'm just going to break it down just so you get a sense of how powerful it can be. So we got two kinds of policies, fundamentally. We got centralized policies and localized. I'm going to start on here. A centralized policy is basically a policy that's created from vSmart and pushed from that central location to affect routing perhaps across the entire fabric. But not only is it done centrally, there's like subcategories there, and that's what it's trying to describe over here. So you can have three different kinds of centralized policies. You can have a control policy, and that would fundamentally affect how the routing is happening. So how those VPNs or how that topology is it full mesh? Is it hub and spoke? I can also push a centralized data policy, but hang on a second. And notice what happened to the control policy, right? I created it up here on vManage, and it got pushed to the controller because that's where the centralized routing happens. But then looks like I can also do a couple of data policies. Well, actually, hang on a second. If it's a data policy, it needs to make its way down to the data plane. So that's what you're seeing here. These two guys hit the controller, but then they're pushed via OMP to this. And so what are these? Well, this is quite clever. So the data plane policies allow me to like work on stuff like policy-based routing, for example. I can manipulate how the routing happens at specific places. And this is one that I've got a little slide coming up, but again, it's pretty straightforward. It's a policy that allows me to say, okay, my voice traffic, I need this round trip time, I need this delay, I need this latency. Look at all my transports and decide which one I should be using, and then roll over if they fail or if they're out of scope for my SLA. So that's what the centralized policies look like. Three different flavors: control, data, and app aware. If we go on this side, you can see right away the difference. It's a localized policy. So as soon as I think localized, it's right on the WAN edge router, that one. So maybe branch 2 has to do something different. So I'm going to push a policy to that device. And what kind of policies can I implement locally? Well, there's two. One is a control policy locally. So maybe I've got OSPF running there, and I'm redistributing, and I need to play with the metric, and I need to adjust some parameters. Well, I would do that with that local control policy. But I can even go further and maybe apply some quality of service on that device, or maybe on a few devices. But notice how those kinds of policies get pushed right to the device itself, because that's the device that's actually doing the work on the data itself. So again, I don't want to spend hours on this one, but I just want to get you a sense of how powerful those policies are and how they kind of break down from control policies to data policies, but also from centralized to localized as well. Are you bored yet? Are we okay? I'm almost done. A few more slides. So this one is kind of cute. It just comes back to the picture I was trying to paint like a few minutes ago, which is the application-aware policy. So imagine we've got 3 circuits, 3 transports. I've got an internet, MPLS, and a 4G. I want to kind of track these, right? I want to monitor these to see how they're performing and report back to the device. And I want to tell the device, you know what? I'm going to create an SLA policy for, I don't know which traffic. They're going to call it what here? For app A. I don't know what app A is. Maybe it's your voice traffic. Who knows? And I'm going to say, I want you to pick the transport that has less than 150 milliseconds of latency, less than 2% loss, and less than 10 milliseconds of jitter. So basically, I want to track those statistics across my different transports, and I want my traffic to take the best one according to that SLA. That makes sense? So that's what it's doing here. We've tracked some information about these 3 different paths, and according to my lovely diagram here, only path 1 matches the SLA, so that's the one it's going to use. If I had 2 that matched the SLA, it would use them both at that point, right? And it would use, listen, it all depends on your policy, but you could then basically tell it as soon as, if one path doesn't actually match the SLA, well then use this one next, right? You can actually tell it to fall back to another transport at that point. Probably some of the coolest things that you can do with SD-WAN is quickly deploy direct internet access. And you can combine that with a couple of things. And I've got basically 2 slides on that. And they're very, very, very similar. Basically, I want from a branch location to be able to hit my services up in the cloud as quickly, as securely, obviously, but as quickly as possible. So with DIA, what I can do is I can obviously leverage that internet connection, but then possibly use that MPLS link as a backup in case something happens to it. And what I mean by in case something happens to it, I don't just mean it's suddenly failed. I just mean maybe it's not performing well enough. So I can actually create a tracker to say, keep an eye on this internet link. And if it starts being a bit flaky, it's not quite good enough, then let's fail over at that point. And we'll use the MPLS link. So let's take that and then combine it with something called Cloud On-Ramp for SaaS. And let's just make it even better. So again, we're using direct internet access, but now not only am I going to monitor perhaps the link through one ISP, I might actually be monitoring the application's performance up there behind Microsoft's firewalls. I can actually track the performance of the application and then fail over again and react and use maybe a different data center if that's the case. Now, this diagram's not showing that use case, but it's still giving you a sense of what I was talking about here in terms of using one ISP for direct internet access and maybe failing over multiple times across different transports and different locations to get to our cloud apps, basically. Okay, I promised last 2 slides. I talked about security, and I gave you a little hint earlier that there's 2 major flavors of ways that you can deploy security with SD-WAN. Either you take care of it yourself, or you give it to the cloud to take care of. If you do it yourself, these are all the things that you can turn on in the SD-WAN network to filter, to protect, to secure your traffic. So a lot of these, you know these already. Firewall, IPS with snort, URL filtering based on the category of the URL, for example, like gambling, alcohol, malware protection to make sure that there's not dodgy stuff coming in on people's attachments. You can even allow the DNS to be handled by Umbrella if you wanted to, instead of your maybe on-prem DNS or your ISP's DNS. And this is quite fancy, obviously. More and more traffic is using HTTPS, using secure connections. So we can actually man in the middle of that, if I can use that term, right? We can grab that traffic, decrypt it, have a look at it, looks good, rewrap it up, send it on its way. So that's all possible with that solution as well. Again, talking about on-prem in this case. And then the other option, as I said, we can leverage the cloud with something like Umbrella SIG, and that's going to give us almost all the same things plus a few extra things. For example, helping us secure our access to our apps, so SSO, that kind of thing. Data loss prevention, integrating with SecureX. But again, notice I came back with the same diagram. We're still maybe using our MPLS links to carry our traffic for our branches to HQ for those servers. But then I'm leveraging Cisco Umbrella and Umbrella SIG for the actual other levels of security within the fabric itself. Ta-da! Now, that was a teaser. I don't know how much time I went over, sorry. So, as I said at the beginning, oh my, I didn't even introduce myself, right? So my name is Patrick Gargano, and I'm a content developer with Learning and Certifications. And the reason I'm talking to you about SD-WAN is because I'm responsible for building the SD-WAN courses that we offer at Learning and Certifications. And we've got a bunch. You've heard of Cisco U, hopefully this week, a lot. We're excited about Cisco U. It's a game changer for us, the way we're delivering and offering our content. Hopefully it's a better experience for you. So I went into Cisco U this morning and I just typed SD-WAN in Cisco U to show you what's available there right now for you to consume. And as I said way at the beginning of my quick talk, there's a few different options. If you just want a short bit of training, we've got a short course. It's called SDW-FND. It's the equivalent of like a 2-day ILT course, right? But here you're consuming it at your own pace. We're talking about 5 labs, 5 courses, about 11 hours worth of content. And that gets you from 0 to, maybe not hero, but 0 to Spider-Man level, right? If you're thinking you're ready to go further, but also you want that training to really help you get ready for the certification exam, then you should be looking at ENSDWI. Now, just between us, don't tell anyone else, I'm currently working on a big update to that course, right? So this is version 2. It runs 20.3 code. It's about 2 years old, the course. Those of you that are familiar with SD-WAN, when you blink, it changed, and you blink again, and it's changed again. It's a technology that's evolving. It's exciting. It's frustrating for me as a content developer because I'm always trying to play catch up to make sure that the content I'm creating for you guys is as fresh and as useful as possible. So ENSDWI 3.0, I'm hoping we're going to be done and it's going to go live sometime in August, maybe end of August. 20.10, 20.11 code, new GUI, brand new labs, all iOS XE, new features like multi-domain and multi-region, or not multi-domain, multi-region fabric. Huge uplift, an update to the course as well. So if you're looking for something that really focuses on getting you ready for that exam, that would be the one to have a look at. Now, the challenge I had when I was developing that course was that I was stuck with, I shouldn't say stuck with, I was limited to 5 days of content because our partners, like I saw Alan somewhere, he's hiding now. Alan's one of our partners. He helps deliver these courses. I had to create a course that would fit in a 5-day mold, right? And then looking at the exam blueprint, I could see it talked a lot about cloud and security. So there is some cloud and security in the certification course, but I felt like I wanted more. So we created another course. It's the equivalent of 3 days of training. And this is I really like this course because it's just security and cloud. And what's cool with this course is it runs on the dCloud infrastructure. So you take this course and you say start lab and you turn to grab your coffee and the lab is ready. Now, I didn't get the response. Ooh, you guys, you need a lot of candy. Okay, it's coming, it's coming. So I think that's a huge game changer. It's a great course. AWS, all the security stuff you can imagine is in that particular course. And again, look, it's right here in Cisco U for you. Listen, there's a bunch of other courses that we have that have little nuggets of SD-WAN, like the Enterprise Automation course has how to automate SD-WAN, so it looks at API calls and that kind of thing. The design course has a section on SD-WAN focusing on how to design a proper fabric, how to design an SD-WAN network. So we've got SD-WAN nuggets here and there, but those are the big 3 where you would proper deep dive into the technology with hands-on labs, okay? Proper hands-on labs. So far, so good. Okay, well, it's time to just be silly now. So we've got a few things to give away. So I'm not sure. Emma, hello. Do we start with the thing under the chair? Okay, so we've got a few things to give away. Apparently we've been giving away fire sticks. Is that it? So if you have a look under your chair, you might find something stuck underneath the chair, a little ticket, something to say you're the winner of the fire stick for our last session today. Going once, going twice. Anybody? Did you get it? Fantastic. I think so. Emma's just grabbing it. Listen, for the second prize, I would really like the book to go to someone who would actually benefit and use it. So what I would like you to do is to raise your hand if you're planning on taking Encore soon-ish. 30 days, 60 days, 90 days, because my book is basically a guide. It's pretty substantial. Okay, so it's, I don't know, 600 pages. It's review for Encore, for the exam, okay? So please raise your hand if you're thinking of doing the exam soon. Emma's gonna come around and give you a ticket. We're gonna do a draw just for you guys, all right? Because I don't wanna give it to Greg. Greg's gonna be like, what do I do with this? Cisco Press. Yeah, for Cisco Press, yeah. They sold out. It has nothing to do with how amazing the book is. I think they just didn't bring in enough. Okay, while she's doing that, we're gonna do a quiz for Candy here. So basically, this is like Canadian gold, right? So it's pure maple syrup in candy shape. All we're gonna do is just raise your hand and tell me something you learned today about SD-WAN. Short answers. Don't give me an epic answer, but just tell me something you're taking away from today, and you get a candy. Yes, sir. Name it. Yeah. Can you give me a new name? Yes. Thank you very much. That's good. Don't do them all. Don't do them all. Yes.
It provides a lot of policies to control.
Yeah. Very good. Thank you. Yes. Gentlemen, please feel free. Any questions? Any transport, thank you. Yeah. OMP for the routing protocol. You guys want to play along? No. Anyone else? I don't want to go home with all this candy, so come on. Guys. Manager. The validator. Nice. Anyone else? Coming along. Catalyst. Yeah, the new name for Catalyst. Anyone else? This is like literally the best candy you've never had in your life. Yes, thank you. Let's have a chat after. Anyone? Yes. Oh, thank you. Yes, very good, very good. Yes, much smoother. Transport colors, T-locks. Anyone? Yes. Well, I'm going to give you 2 for that. Yes, VPNs, VRFs, the same thing. Hello. Okay, you can have one anyways. Gents? Yes, thank you. Validator. Yeah, easy stuff. Anyone else? Okay, yeah. I don't want to go. I don't want to go home with these. So, V-bond, yeah, for sure. Anyone for? Thank you. T-lock, thank you. You want another one? Fair enough. Scott, because I love you. Steven, because I love you too. There you go. Thank you. Anyone else has not? Okay, there you go. Have one. You get 3 because you put up with me the other morning. Anyone else? Yeah. No worries. There we, yeah, exactly. You get 2 for that. There you go, dude. Thank you, everyone. Thanks for coming. Really appreciate it. Cheers.